Hi students, problem number 4. A simple pendulum is suspended from the roof of a school bus which moves in a horizontal direction with an acceleration a. Then the time period is to be determined. Now suppose the simple pendulum is suspended inside the bus and the bus is at rest. Okay. So bus is at rest means now the pendulum is oscillating with a period t is equal to 2 pi into square root of L by G. This is the standard expression for finding the period of oscillation. If the bus is at rest means this is the expression. But actually bus is moving in the forward direction, is it not? The bus is moving in the forward direction with an acceleration a, and here it is having an acceleration due to gravity g in the vertical direction. So we have to draw a vector picture for better understanding. Vector picture. Acceleration a is acting along the horizontal and acceleration g is acting perpendicular to the horizontal, that is along the y-axis. So when two vectors a and g are perpendicular to each other, what is the resultant acceleration vector we have to find out, and its magnitude we have to find out. So g dash. So here g dash square is equal to g square plus a square. Therefore what is g dash alone is equal to square root of g square plus a square. Therefore now we have to substitute t is equal to or 2 pi into square root of, okay, or t dash I will take, okay. So this is equal to square root of length divided by g dash. This is when the bus is moving with an acceleration a. So this is now equal to 2 pi into square root of L divided by, this is what, g square plus a square, is it not? So square root of g square plus a square, or t dash is proportional to 1 by square root of g square plus a square. So this is the expression for the period of oscillation when the bus is moving forward along the horizontal direction with an acceleration a. So which is the option, let us see now. So t is proportional to square root of g square plus a square. So option B is the right answer. Therefore option B is the correct answer. I hope you must have understood well. Fine.